Welcome to another video. Let's solve the value of x in this problem. So, looking at this, if I transfer 81 raised to the power x to the other side, so we have x raised to the power 12 equals to 81 raised to the power of x. And then this 12, if I break it into two, we have s to the power of 4, then everything raised to the power of 3 equals to why this is 3 raised to the power of 4 and all raised to the power of x. So from the look of this, we should conclude that the value of x here equals to 3. So I'm getting this. So we know that this x equals to 3. So it's just like the integer here is 3 far. So let's see another way of doing this. So this 3 satisfy this, but in another way, if I try to bring back the equations, so we are going to have x to the power of x, x to the power of 12 equals to 81 raised to the power x. And if I introduce logarithm to both sides, so we have ln of x raised to the power 12 equals to ln of 81 raised to the power x. And by rewriting this as 12 ln x equals to x ln 81. And so I want to separate x and 12 separate. So we divide both sides by 12.x so that we make only x separate and the number separate. So this two will cancelled. So this will also cancelled. Then, so this is written as x raised to the power of minus 1 ln of x equals to ln 81 divided by 12. So looking at this, if I try to, let's say if I introduce exponential to both sides, so just to have this, we have exponential of minus ln x. So dot ln of x equals to ln 81 divided by 12. And so let's introduce negative to both sides. So we have negative ln x exponential negative ln x equals to negative ln 81 divided by 12. So the reason for this is I want to apply the Lambert W functions, so that's why I introduce negative, so just to make the exponential and the coefficient balance. But we should know that if you have negative exponential of minus 1, so because this is exponential of negative 1, so the value of it will always less than negative ln 81 divided by 12, and this is also less than 0. So which means in this problem, we might possibly get the two different values. So for this condition, and getting the, so now we introduce the w, which is the Lambert omega, so function. So and we have negative ln x exponential of negative ln x equals to omega of negative ln 81 divided by 12. So getting this, we have a constant value, which is if you have y exponential y, so this is always constant, and we get y, and that y here is minus ln x equals to w of negative ln 81 divided by 12. So then if I transfer negative, or let's say I divide both sides by negative, so just to make only ln, then we have ln x equals to negative w of negative ln 81 divided by 12. So the question says we find the value of x. So and what we're going to do here is by introducing the e to both sides, and that e is exponential because the exponential and ln, they are inverse, they cancel each other. So that is the essence of introducing it here. Then we have exponential of minus omega of negative ln 81 divided by 12. So these two will cancelled. So I mean the exponential and ln will cancelled. Hereby we have x equals to exponential of negative w of negative ln 81 divided by 12. So A is not the final solution because so there are two possible values for this. at omega negative 1 and omega 0. So what you are going to do here is, so by writing this, x equals to, so for the negative 1, so we have exponential of negative omega at 0. So and then we have bracket negative ln 81 divided by 12. So and at omega equals to negative 1, so we're going to have x equals to exponential of minus omega at negative 1. So brackets negative ln 81, so divided by 12. And if we want to know the real root for this, so we can press this in Wolfram alpha, then we get the value of x. And this is how to solve this problem. I hope you learned something today, and if you have another way of doing this, you can drop it in the comment box. Let's learn together. And don't forget to subscribe to this channel and like this video. I will see you in the next class. Never stop learning. Bye bye.